Okay, so today we talk about the Pythagorean theorem, and it says the Pythagorean theorem, use the Pythagorean theorem to find the lengths of sides of triangles. So legs of a right triangle, it says these are two sides of a right triangle that form a right angle. So they form a right angle. So if I just sketch in a right triangle here, I have to have a right angle on there. I'm going to name my triangle pi. And the legs for this triangle would be the two sides that form that right angle. So this right here would be a leg, and right here would be a leg. Okay, the hypotenuse is the side that is opposite of the right angle. So if I start at this right angle and I go to the side that's across from it, we call this the hypotenuse. The hypotenuse. One thing that we know about the hypotenuse is that it's the longest side of the triangle. Okay, so in working with the Pythagorean theorem, it says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. What that's saying is if I take the hypotenuse and I square it, it's equal to the leg squared plus the leg squared. Okay, so really this is saying c squared is equal to a squared plus b squared. In the past, you might have heard a squared plus b squared equals c squared, okay? So it's the same idea, they're just switched around here. What I know is that the c squared always has to be the hypotenuse of the triangle, so the side that is across from that right angle. Okay, number one says find the length of the hypotenuse. So what I'm going to do is I'm going to add these two legs squared. So I'm going to say 5 squared plus 12 squared is equal to x squared. Remember, x goes at the end because it is the hypotenuse. Okay, 5 squared is really 5 times 5, which is 25. 12 squared is 12 times 12, which gives me 144, equal to x squared. When I add the two values together, I get 169 is equal to x squared. From here, to get rid of the square, I need to take the square root. So I'm taking the square root of 169, and if I take my calculator, whoop, that's kind of hard to see, calculator, and I go the square root of 169, I end up with x equal to 13. Okay, so same idea for the next triangle. Okay, I'm going to start and say 20 squared plus 21 squared is equal to x squared. Now, it really doesn't matter which order I put the 20 or the 21. These could change. I have to have the hypotenuse at the end. Okay, so 20 squared gives me 400. 21 squared, remember it's just 21 times 21, is 441 equal to x squared. If I add these two together, I get 841 equal to x squared, taking the square root of both sides. So the square root of 841 looks like we get 29. So our x value here is 29. Okay, moving on. The next one says find the unknown side length. Now the difference between these and the ones above is now we might be given the hypotenuse and we have to find a missing side. Okay, so that x is going to move around in the equation. So like this one right here, I just square the legs, so x squared plus 7 squared is equal to the hypotenuse squared. Remember, the hypotenuse always has to go at the end of my equation. So I have x squared plus 49 equal to 14 squared gives me 196. Okay, now I want to get x on a side by itself. So what I do is I subtract the 49 and I get x squared is equal to 196 minus the 49 would leave us with 147. Okay, my last step is to take the square root of both sides. So if I go the square root of 147, looks like it gives me 12.12. Okay, so I'm going to say this is approximately 12.1. We're going to go to one decimal place, so to the nearest tenth. Okay, same idea for the next problem. I identify my hypotenuse as 53, so that goes at the end of my equation. Doesn't matter which order I plug these in. I'm going to say 28 squared plus x squared is equal to 53 squared. If I take 28 squared, I end up with 784 plus x squared is equal to 53 squared is 2,809. If I subtract the 784 from there, I'm going to be left with x squared equal to, I think it's 2,025. Yep. From there, if I take the square root of both sides, so I want the square root of 2025, I end up with x equaling 45. And that's my final answer. Okay, on the next one, I'm going to say 1 squared plus 1 squared is equal to x squared. Well, 1 squared, 1 times 1 gives me 1. 1 squared again is 1 is equal to x squared. From here, I end up with 2 is equal to x squared. And if I take the square root of both sides, I'm going to find that x is equal to. So if I go the square root of 2, I end up with 1.4. And that's my final answer. Okay, moving on to these ones on the bottom. So same idea, same practice. Might be a good place to pause if you want to try it out for yourself and then check them together.
Mrs. Poppy, you have a phone call on line 1. Mrs. Poppy, phone call on line 1.
So we have x squared plus 6 squared equal to 10 squared. Remember, these two could switch if we wanted to. I'm going to have x squared plus 36 is equal to 100. If I subtract 36 from both sides, I get x squared is equal to 64. My last step here is to take the square root of both sides, and I end up with x is equal to 8. Okay? How about that next one? I could set it up as 15 squared plus x squared is equal to 17 squared. Remember, the hypotenuse always goes at the end of the equation. Okay, so here I have 225 plus x squared equals 289. If I subtract the 225 from both sides, I'm going to end up with x squared equal to 64. And if I take the square root again, I get x equal to 8. So same answer as last time. Okay, last one on here tells me to find the unknown side length. If I go across from here, there's nothing there. I'm just going to put an x there. That's what we're going to try and find. Okay, so here I'm going to go 7 squared plus 8 squared is equal to x squared. Why is x at the end? It's because it is the hypotenuse of this triangle. Okay, so here I get 49 plus 64 equal to x squared. If I add those together, I get 113 equal to x squared. My last step is to take the square root, and if I go square root of 113, I end up with 10.6. And that's going to be approximately x. Okay, one thing that the assignment asks for today is it asks if the numbers are a Pythagorean triple. So if you want to add this, a Pythagorean triple, it has to be 3 whole numbers that form a right triangle. Okay, so on your assignment, what it's going to ask you to do is find the length of the missing side and then determine, is it a Pythagorean triple? So if I go back and look at this problem, my side lengths would be 7, 8, and 10.6. So this one I would say, no, it's not a Pythagorean triple because I got a side length that's a decimal, and the Pythagorean triple has to be whole numbers. Okay, if I go back to number 7 and I look at the sides, I have 15, 17, and 8. They're all whole numbers. I would say, yes, that's a Pythagorean triple. Okay, going back to this one here, I got 6. This side length was 8. This side length is 10. 3 whole numbers means, yes, it's a Pythagorean triple. Okay, I could keep going. Looking at the next one, I have 1 and 1 and 1.4. Since I have a decimal here, I would say, no, it's not a Pythagorean triple. And that's the idea of Pythagorean triple. So, worksheet for today. Have a great day.